Having cleaned up everything that was unused, the next goal is improving one of the stub implementations. The current implementation of RTC Encryption Provider returns a fixed password which is not secure. I want to have per document secret keys that are regularly changed. A new database table is needed to contain the secret keys. Stop the server process by pressing Ctrl+C in the left side terminal. Create a new migration with yarn space connects space migrate make space add underscore keys. Open the file in the migrations folder that has a number followed by underscore add underscore keys.js. In the up function, type a return statement followed by the function call connects.schema.createTable. That statement will create a new table. Set the inputs to be the following: the string keys, which is the table to be created, an inline function with the single argument table, where the table is defined. Inside the function to define the table, create a column to hold the document ID by calling table.string, passing the column name as the string document. Add a non-null constraint to the document column by chaining the call not nullable. Create a column to hold the key creation date by calling table.datetime, passing the column name as the string created. Add a non-null constraint to the created column by chaining the call not nullable. Create a column to hold the secret key by calling table.string, passing the column name as the string key. Add a non-null constraint to the key column by chaining the call not nullable. Add a primary key constraint by calling table.primary, passing the two table columns, document and created, as a list of strings. Add a foreign key constraint by calling table.foreign, passing the column name as the string document. Chain the call references, passing the table and column as the string documents.uuid. That covers creating the table. In the down function, drop the newly created table by typing a return statement followed by the function call connects.schema.dropTable if exists. Pass the table name as the string keys. Save the migration file. In the left side terminal, run yarn space connects space migrate : up to apply the migration. Now I want to create a server route to generate or retrieve the keys on demand. The route needs to be specific to the document and take an optional key hint for when a pre-existing key is to be returned. In this case, I've already decided that the key hint will be the creation date of the key using the ISO 8601 standard. Copy the route for getting the title as it has the basic structure I need. In the copied route, change title to key in the route path. Change the database query return value to be rows, as I won't always have a single value I can extract. For now, delete the title variable from the route return value, as I will need to return the key and key hint instead. Change the select call to request key and created. Change the from call to request the keys table. Change the where call to compare document instead of UUID. This database query will get all the keys for the document, but it needs to be more specific. If the key hint has been provided, it must get the key associated with that specific key hint. If no key hint is provided, then it must get a key that was generated recently. To support these queries, I will put the key hint and current time into a variable. Set key hint equal to req.query.keyHint. Set now equal to datetime.utc. Since this needs different where clauses for each of the options, I'm going to use the connects feature, which allows building the where clause with a function. Append the call and where after where in the method chain. Set the input to be an inline function with a single argument, builder. Add an if statement checking the existence of the key hint, providing if-else branches. In the branch where key hint exists, call builder.where with the inputs: the string created, which is the column name, the quoted symbol equals, which is the comparison operator, and the variable key hint. This will modify the query to only get the entry with the creation date equal to the key hint from the database. In the else branch, also call build.where, however with different inputs: the string created, which is the column name, the quoted symbol larger than or equal, which is the comparison operator, and a date time string 1 hour in the past, generated by calling now.minus with an object containing the property hour set to the value 1. This date is then converted to a string by calling toISO. This will give us all keys created in the last hour, though their ordering is not specified. I will ensure that the newest keys are listed first. Append order by, after, and where in the method chain. Set the inputs to be the string created, which references the column to sort on, the string DESC, which causes the column to be sorted in descending order. Now the rows value will contain either the requested key if key hint was provided, or the more recently generated keys if any exist. Add an if statement checking if rows has a length larger than 0. In the if body, add a return statement calling res.json with an object containing the properties success equal to true, key equal to rows0.key, and key hint equal to rows0.created. This will return the result found in the database. When there are no rows, we can still generate a new key. However, if a key hint was provided and there are no rows, then an error must be returned to indicate that a result was not found. Add another if statement, checking the existence of key hint. In the if body, add a return statement calling res.status, passing status code 404, which means not found. Chain this method with a call to JSON with an object containing the properties success equal to false and message equal to the string could not find the requested key. This ensures that I don't attempt to generate a key when the key hint is provided. Finally, when no specific key was requested and there isn't a recent key in the database, I need to generate a key. The key can be any string, so for convenience, I'm going to convert random bytes into a base 64 string. At the top of the file, add a require call to import the crypto library that comes with Node.js. Back in the function, set key to the result of calling crypto.randomBytes. passing the number 192, then chaining the method toString, passing the string base 64. This will generate a key that is 256 characters long, as the base 64 conversion means that every 6 bits will become a character in the key. However, any number would work, so the choice of 192 is mostly arbitrary. Insert the new key into the database by awaiting the call to req.db.insert, passing an object containing the properties. Document equal to req.params.document_uuid. Created equal to the call now.toISO. And key, which is passed the key value calculated above. Chain the method into, passing the string keys as the table name. Finally, return the generated key from the route. Add a return statement calling res.json with an object containing the properties success equal to true, key equal to key, and key hint equal to now.toISO. Save the file. Now restart the server by running yarn start in the left side terminal. Now a server-side route exists, I can create a helper on the client side to call the route whenever RTC requests a key. Open the API.js on the client side. Create a copy of the getContent helper and rename it as getSecretKey. Change the end of the path to be /key instead of /content. That's most of the changes needed, except I need to pass the key hint when it is provided. Add key hint to the inputs after document ID. Add a second argument to the axios.get call, passing an object. Add a property to the object called params and set the value to an object. Put the key hint into the params object. With that complete, open the document edit page and return to the stub implementation of RTC encryption provider. Replace that stub with getSecretKey, importing it from the API. Save, switch back to the web browser, and refresh. The editor now fails to load again, but this time due to an encryption error. When I check the console, the specific cause is could not find the requested key. Before, I was returning a fixed key, but now I'm returning keys from the database, but that fixed key is not in the database. There are two options. I could abandon this document and start a new one, or I could put the key we used before in the database manually. I will demonstrate the second option. Open DB browser for SQLite. Open the dev.sqlite3 file in the server folder. Select the Browse Data tab. Select the Keys table from the drop-down menu. Press the New Record button. Switch back to the browser and copy the document ID from the page URL. Paste it into the document field. Type the timestamp we previously used for our key hint into the created field. Type the key, "This is not secure, fix me," into the key field. Press the Save button. Press the Write Changes button. Switch back to the web browser and refresh. The document loads successfully again.